right. Hi, everybody. Welcome to today's webinar where we're going to be diving into how you can efficiently scale battery production. My name is Ellie Allen Bathe, and I'm a content marketing manager here at Flexware. Before we get started with introductions today, just a couple quick housekeeping notes. First, if you have any questions throughout today's presentation, feel free to drop those in the questions tab of the toolbar. We'll answer those when it's applicable in our discussion, and we'll leave some time at the end to answer any other additional questions that come up. Secondly, today's session is being recorded, and we'll make that recording available to you shortly after we wrap up today. Now that that's out of the way, I'll introduce today's panelists. I'm joined today by Gabe Holmes, Ben Reitzman, Anthony Sebastian, and Chip Siebold. Ben is an industry executive with more than 30 years of experience across advanced battery, high-tech manufacturing, and turnkey electronics. His recent work has focused on advising organizations on energy storage, global supply chains, and critical material recycling. Chip Siebold is the Director of Sales and Global Energy and E-Mobility Market Vertical Lead at JR Automation. He has over 35 years of experience in technical sales and applications engineering across military, automotive-grade semiconductors, automotive chassis, powertrain and body electronics, and XEV and ESS battery module and pack assembly lines. And then Gabe is a solutions consultant at Flexware Innovation. He has over 18 years of experience in the battery industry, spanning automotive, energy storage, and defense applications. He brings deep expertise in the full battery value chain, including cell, module, and pack manufacturing, as well as system design, deployment, testing, and validation. And then we have Anthony Sebastian. He's the industry principal lead for industrials at Flexware Innovation. And in his role, he partners with industrial manufacturers, including battery, to help streamline and modernize their operations. And he will be serving as today's moderator. So with that being said, Gabe, I'll hand it over to you to kick us off.
Yeah, LA, thanks for the introductions. And thanks everyone for joining today as well. So the purpose of this session is really twofold. First, we want to discuss what we've seen with deploying and scaling battery manufacturing in today's North American market. And second, we want to start, call it the broader conversation from our side around how the industry can approach the challenges that we've seen with deploying and scaling in a more systemic way. So our goal here really isn't to present any single solution or promote a specific product. It's kind of to raise awareness around the real constraints and design considerations that come into play as manufacturers move into full-scale production. So we're also hoping this serves as a starting point for continued dialogue across the industry. There's a lot of innovation happening, but most of it seems to be, or at least a lot of it seems to be fragmented, if you will, and kind of bringing those perspectives together is critical, we think. So with that, I'll hand it back to our MC here, Anthony.
Thanks, Gabe. Great kickoff. Kind of, to follow suit with your introduction there, why is scaling efficiently such a critical focus for battery manufacturers right now?
That's a great question. Things are really expensive, right? Coders and stackers off Amazon are pretty pricey. From what we're seeing across the industry, there's been a clear shift from, call it, rapid expansion to really disciplined scaling. So even as recent as a few years ago, success was measured, by how quickly you could stand up capacity. And now it's about how efficiently you can operate that capacity, right? So we've seen almost a methodical dialing back in the approach towards standing up production, just with the way things are in the current market. So manufacturers are under pressure from multiple angles. Capital is certainly tighter, policy timing definitely less certain right now, and globally, we're competing with highly optimized operations, especially in Asia. That means, yield throughput and cost control are now kind of the primary levers, if you will, that need to get pulled on. And at scale, inefficiency compounds quickly. So what we're seeing is a much stronger focus on getting the process right early, because as we've all seen, mistakes are significantly more expensive once you're operating at high volumes. I guess, Ben, I imagine you're seeing that shift reflected too, with all the stuff you're involved in, and maybe, what are your insights there as well with some of these efficiencies you've seen, some of the shifts in the industry towards standing up production?
Yeah, great question, great lead in. I think what we've seen is, the U.S. is really not across the board, but at the kind of the first movers, mid movers, and also kind of the high tier level. This shift from the prototype, into the pre-production and then into production, and the mindsets really have to shift. And frankly, even the cues that we used, 10 or 15 years ago in production, we can't use today. You put it very well. Asia is way out in front at this point in leading on capitalization, how they deploy that equipment, their efficiencies. Obviously, they've got some optimizations in there as well. There's some, financial optimizations that happen government incentive wise as well. However, if you look at the technical aspects of it, really not borrowing cues from the prototype or even the thin film coating deposition that we knew of, of yesteryear. Even that has been highly rapidized, highly optimized, has become much more efficient as part of that perspective. And probably the biggest move is, it was the kind of the people to automation, but it's not just people to automation. In fact, automation is not enough. It's people into complex systems and adding artificial intelligence and everything on top of that automation. So big moves, and if there's the biggest thing, it's how fast we can go from prototype to production and moving kind of people and automation maybe away from the process and optimizing for the technical readiness of the product as well.
Awesome. To build on that, I guess is the next question. One thing that we're seeing is a delay. It's a delay as manufacturers set out to build gigafactories. Many are encountering these project delays. What do you guys think is driving these setbacks?
Yeah, I'll take that one. So we've seen this across cell manufacturing, module and pack manufacturing, and so a big factor is that many early facilities essentially weren't designed with full-scale automation and integration in mind, right? We've seen this numerous times. They were built to get production started quickly, but not necessarily to sustain high volume or a high consistency output. What that leads to is heavy reliance on manual processes, right? And that's not necessarily a bad thing as long as they're well defined and ran, but things like manual setup, operator dependent checks, disconnected handoffs, these things all introduce variability. And as you scale, that variability shows up as things like scrap, yield loss, slower ramp to those timelines that they're targeting. So we also see challenges in areas like formation, for instance, right, where throughput and data management become pretty big bottlenecks. And as of recent, even in dry rooms where material handling and environmental constraints add even more complexity. And ultimately, a lot of these systems weren't architected for modern capabilities like closed loop control systems or things like even predictive maintenance, which are becoming more and more essential. So I'd be interested, maybe Chip, from your side, how do you see kind of these challenges manifest when you're actually, delivering something like a modular pack assembly line?
Well, for us, it really started pre-pandemic. We had availability of technology really on a global scale, whether it was designed and built in Europe or Asia, we could bring that technology onshore quickly. That kind of dried up. And so it put a lot of emphasis on supply chain development and allocating inventory such that we could minimize long lead materials and the impact on a program. So many of our customers early on, they tend to not have a product that's fully frozen. And so from that point, we can actually kick off when we know a line concept and overall footprint is understood and process flow is understood, we can kick off long lead technology vendors that are not interfacing with the product per se. So we can hold off on kicking off touch tooling and things of that nature. So we can get ahead of it to kind of bring it in as needed to scale appropriately. Yeah, I think that's probably our perspective on that.
And I know you're in the weeds on a lot of stuff related to this. I guess maybe you have some examples too of some of the setbacks you've seen with customers just in terms of deployments and scaling.
Yeah, I know one of the, and it's a great question, kind of a lead. If we look at, you, and I'll focus on U.S. factories, by the way, and maybe a compare and contrast versus Asia. You hit on one key point is predictive maintenance. I think a lot of the factories, again, are trying to replicate, the prototype or the pre-scale process. And back to my earlier note is they're also trying to replicate some of our, I'm going to call it legacy tech now. And that's just because, again, Asia is so far out there with their technology that a lot of the stuff that we're seeing companies deploy are equipment that we've kind of all known. I've been in this industry since the beginning of it, started coming in, with lead acid and nickel metal hydride, the very early days of lithium ion, and looking at our techniques then. And if you look at some of what we're deploying in the US, we're still counting on some of those legacy techniques. We're also counting on some of those legacy setups. And so I can't use by name because I don't want to call anybody out who may be even on this call. But a couple of them, when I looked at some of the equipment, they were pretty proud of their brand new equipment. And they're like, hey, this is, innovative equipment. And we're like, that's actually equipment that, is in a lot of other factories, and it's actually being taken out of those factories because of, again, risk of downtime, first pass yields, efficiencies that are there. Again, it's a purely automated piece of equipment, but how is it tying in artificial intelligence? Yes, it's kicking out data, but what is it doing with that data? A lot of manual manipulation. Again, I'm amazed. I think if you look around and watch if you don't even know the factory as well, you can start to review the news articles that, so and so opened their factory and had a project kickoff, and then you look at how many people it says that they're planning to employ and hire. Compare the people per gigafactory needs of like some of our US scale versus some of the international scale, and it's orders of magnitude. We're not talking, a few hundred people to, a few hundred more people. We're talking about factories that require like maybe a couple hundred people and others that require thousands of people. So that's one of the biggest differences that we see is also the setup of that technology. It's I'm gonna say it's legacy at this point or mature at best, but it's not leading out into optimizing optimizing automation and also efficiencies, predictive maintenance, getting rid of manual operators. Again, I'm not against having highly skilled operators in there, but if you've got folks that have to move product from line to line or having to do manual verifications where you can, automate that, you can use thermal, you can use, AI, you can use, again, predictive maintenance measures to know whether equipment should be maintained versus waiting till it breaks, and having to have personnel and staff for that. Those are all things that are behind and delayed. My last point is first pass yields as well. We have seen, and again, this is kind of a chemistry scaling technology issue, is some of those that are not using their data from the pre-manufacturing process, and it's the old like iterate until you get it right. And so first pass yield for some of our US factories are way lower than they really should be. Again, back to lots of manual manipulation. That setup time is in months, some of it, 12 to 18 months of setup time to be able to get going. And their first pass yields are, in some cases, they're throwing out first product for, 6 to 9 of those months. So you're throwing away tons and tons and tons of product, and we're not feeding that data back into the system to optimize it quicker. So that's the other delay we've seen, is a lot of product that winds up going to the trash can instead of going out into the revenue field.
Kind of along that same vein, Ben, we talked on or touched on, why automation is essential for scale. But where should a manufacturer prioritize automation? What types of automation should be the priority?
Yeah, I mean, we can, we could probably go along into each of those processes, but, Gabe touched on formation for sure. Formation. I'm, again, still kind of blown away by the number of folks that have much more manual touch points in the formation process. Cells come off the line, they're handled, and or they get, reconfigured and or get stored, versus being able to flow through directly into automation, or sorry, direct with automation, being able to flow into formation. Number two, some of that gets staged up because of the data feedback requires operators to look at it, and then they may go tweak levers, turn knobs, adjust recipes, adjust materials and process through automation. And again, with AI and, and data and machine learning, again, some of these are, I'd say very mature technologies, AI becoming more and more prominent. Why are we not letting the equipment adapt on its own and just reviewing if that adaptation makes sense? So if we see in formation things happening, instead of that manual manipulation, that's one big area. Number two that we've seen, and actually a good friend of mine, BJ, and I have talked about on the coding side, optimization of coding. There's a lot of first pass codings that get thrown away. And by first pass, I mean, in some cases they're throwing away hundreds of thousands, if not, approaching, a million cells worth of material in the coding process. Why are we not using data optimization, our sensors and automation to be able to let the coding equipment tweak where it needs, tell the operator what it's seeing, and let the operator, make those adjustments, and or the machine making those adjustments appropriately. So we know those two areas are pretty big ones, and you can unpack through some of the others with, drying, with mixing parameters and others. Those are all areas where we have today probably too much waste in the United States with our manufacturing. That legacy used to be okay, but if we compare to where China is today, they've been able to refine and optimize, and through automation and AI, perfect those processes. And I think that's the key, is they've moved from a production state to, I won't say perfection state, but being able to tweak to that perfection state. They're playing with, final digits past the decimal point. We're still playing with digits on the main side of the decimal point.
Awesome.
Yeah, I guess, yeah, maybe to add on a little more, Ben. So one of the biggest misconceptions that I come across is that automation is primarily about reducing labor, when really it isn't. And I'll keep my scope just to battery manufacturing, but what I see is it's more about stabilizing the process, right? You're dealing with highly sensitive processes where small variations can have huge impacts on the performance of the output, right? So the automation needs to focus on, consistency, repeatability, and control. So you mentioned it, we talked about from a priority standpoint. We see a lot of that, like you said, in things like formation, and then also in things like inline quality checks, even looking further to what's ahead, like inline SEM, and then closed loop control for kind of the upstream processes of coding and stacking, right? But the key point is that automation on its own is just not enough, right? It's not. If the systems aren't integrated, you end up with data that's isolated and not actionable, which we hear this now weekly. I actually heard a term that I'm gonna steal, but it was data waste, right? They collect all the data, they have all of it, but it's not organized, it's not contextualized, and they can't really make sense of it to do what they need to do from a quality standpoint. And I think that's a pretty accurate way to put it. So
Awesome. Kind of a follow-up, one of the challenges that we've been hinting around is around the strategic gap between ideation and actual execution. How can manufacturers close that gap to move to more measurable ROI that ensures long-term success?
I can take this one first if you want, if that's okay. So, being able to focus and execute, right? There's no shortage of great ideas. We've seen several battery companies, for example, who were also trying to build things like their own MES or their own SCADA in parallel to scaling up, which ultimately just ground things to a halt, right? Because of the complexities and nuances involved in deploying these other systems for their operations. So even at times, it almost felt like some of these companies were going through an identity crisis. So one of the patterns we see a lot is strong innovation kind of at the pilot level, but difficulty translating that into full-scale production. And that usually comes down to a lack of a clear roadmap from pilot to scale. And I'm referencing, I'll use cell manufacturing here in the example, right? So there's often heavy investment in technology, but not enough focus on how that technology will operate in a production environment. So to close that gap, manufacturers need alignment across equipment, automation, and digital systems from the beginning, and they need a clear path to ROI, just not a proof of concept. So And we see this more and more, that there's a much heavier focus on how these digital systems, one, will work, and two, integrate to the existing overall plant architecture and equipment operation. So success comes when there's a clear understanding of how the line will operate at scale before it's even built. I guess, Ben, did you want to elaborate any more on that one? Sorry, I know I went a little far there.
No, Gabe, you're spot on, and I think that's the thing that a lot of folks miss is, you know, and I'm not going to knock the science community, but a lot of times as we transition from science to production, you know, I think folks believe that we can almost kind of science our way, you know, out of or science our way into scale. By the way, the right selection, being able to replicate that recipe consistently. To Gabe's point, it's very, very succinct, and there is a science piece of that, is that I have to maintain the level of control that I had, you know, at the droplet down on the coin cell level. In fact, even more tightly in a lot of cases, up through, you know, whatever cell format that I'm going to build. So how do I build that consistency in is number one, and I have to scale it and actually tighten those parameters up. Number two, I would piggyback on what Gabe was stating there. As I think about the equipment, I'm amazed how many companies we talk to have already got all their equipment, or their equipment manufacturer or manufacturers. By the way, folks, even worse, if they start mixing a lot of different manufacturers, how are they going to tie those systems together? And then what's the backbone behind it? I think a lot of them, you know, Gabe said an earlier point, a lot of them are like, well, they've got data, you know, coming out of the machine, you know, we'll just tie that together. You know, it used to be, in God we trust, all others bring data. Well, that's not sufficient anymore. What are we actually doing actionable on that data, and how you tie them together? So it's important to get the science right. And I think you wouldn't be scaling if hopefully you don't have the science right. If not, this whole conversation is not for you probably anyways. You probably need to go back to that. Number two is then, how do you make sure that you select your equipment and your infrastructure succinctly? And then to Gabe's point, what's the backbone that's behind that? You've got to have a factory backbone that runs behind that. And if you look at the best in the world, and I can pull one out as an example, they're the best. I will say they are the best and the biggest. I've seen everybody globally. There's some great players, but they really are leading, is CATL. And again, not saying they're the only one, but if you look at them as kind of a litmus test for others, they have, you know, scaled that to the point where their backbone is what the system runs on. I mean, they're in a fully automated blacklight factory from that perspective. The human beings are going in to make sure the machines are doing what they're reporting. But that's really it. So it's amazing to see when you watch that at full scale, at the size that they are, when it's, again, to that perfection level or near perfection level, how this can work. And I think while not everybody's going to be a CATL, nor do we need every factory to be that big, we can borrow some cues, though, from some of the best from that perspective.
Right. Kind of keeping on with that same vein, Ben, I'm going to toss this back to you. So we talked about data. Traceability, a big piece of data, is a critical component of quality, right? As manufacturers scale, what is key considerations that they should keep in mind to ensure robust end-to-end traceability?
Well, definitely first pass. And I think I'm going to break that down even further, in that it used to be first pass, you know, at the end of formation, we're looking at what we have, we're grading our cells, you know, and as Gabe and I, you know, originally started in one of the battery factories we were in together, our grade card, if you will, started after formation. You know, we had grade A, grade B, grade C cells, you know, and then we had some grade D that we mixed in there. That was grading our process. And, you know, again, we would take that and eventually refine it back in, but there was no real-time tie. Number two is, when we were looking at first pass yields, we weren't breaking down into core areas like, how are we doing first pass checks at mixing stage? How do we know we got our viscosity right? You know, how do we know that we've got a slurry that's got, you know, the blend that we expected? Are we doing, you know, our appropriate, you know, checks of the materials in that stage? And then you work up from there. Again, Gabe talked about in-process verification, coding. We've got some amazing technologies out there with, you know, laser measurement, with optical measurement, with drag web measurement, that those kind of deployed automation and in-process checks on board of a appropriately selected coating system can let you know if you've got your coating optimized and are you running within tolerance or you're running out of tolerance long before that has gone through an entire expensive and lengthy process to have the baby born and then say, yeah, that's a grade B, not a grade A. Well, yeah, we've been trending grade B for the last 6 weeks. And oh, now we go look at the data, we're into C level cells. Why are we already away from A that far? That's the piece that misses. And so each of these processes to succinctly walk through from coating, mixing, post electrode, again, a lot in post electrode that you can look at. And formation is really, are you doing it right now? It used to be, is it right or not? Now it's like, is all the other stuff in line from that perspective?
I want to add on just because traceability is one of my favorite topics. And, we mentioned it before, right? But as production scales, traceability becomes just absolutely critical because the cost of defects increase dramatically, right? So the reality is manufacturers need full genealogy. Their ability to trace every cell, module, pack back to its materials, process conditions, and equipment. But just as important as closing that loop is things like taking the field performance data and feeding it back into manufacturing to understand things like early life failures or long-term degradation. Ben, you mentioned CATL. I mean, they're great at this. BYD also does this too and feeds this back in from a field failure standpoint. But that's what enables continuous improvement, right? And more advanced strategies like the refined grading. And we see a gap too that we've been looking at lately between LIMS, so lab information management systems, and connecting that to production. So right now they're kind of almost islanded systems, if you will. So when I say production, I'm talking about manufacturing execution systems, MES. So we've been trying to identify ways to close that gap, right, to where traditionally, LIMS and MES are loosely integrated, right? So, manual uploads, there's batch IDs, there's delayed syncs. Lab data is often disconnected from real-time production. We see that very much. And trying to unify those to where things like, lab samples, for instance, are kind of born from the MES genealogy, and test results are automatically tied to things like lot batch, serial numbers, equipment state, process parameters, operator actions. I love to dive deep on this one, but I want to hear from Chip. So I want to hear kind of how does JR Automation, achieve, call it closed loop traceability within your turnkey battery module and pack lines you guys deliver.
For us, it all starts with the incoming material, the cell itself. So we actually capture the barcode for each cell. We do open circuit voltage and AC internal resistance testing for each cell. That data is stored. And then as each cell is installed into a tray, which will ultimately become an array or a module, that module is sitting on a palletized conveyor with an RFID. So all sequence of operations from cell, test, sort, and load through module assembly and pack assembly and end of line testing and out the door, every step of the process, that data is captured. So if any point in the process we have a failure, whether we're doing some high pot testing or some resistance testing, we can go back to, did we have a bad weld, or did we have a bad cell, or did we, so we can quickly get that data back to the manufacturer and request root cause. In fact, we've had many of our customers ask us to verify that the data sheet from the cell manufacturer is actually matching what we're getting tested. And so when we see deviations from that, we can give that data to our customers and they can go engage the cell manufacturer on the fact that they're not shipping to spec. So, but that data is all acquired at the very beginning and managed throughout the process. So we do have complete closed loop traceability all the way down to the cell level.
Wow.
The data sheet test is well known, isn't it, in the battery industry?
The what?
The data sheet test. The data sheet test.
The data sheet test. It sure is. Yeah.
That's right.
Yeah.
I was going to piggyback too on what Chip noted, and also follow one line down on that traceability is the right cell, but also with the EU passport, with battery traceability, with some work that's going on with SAE, NatBat, and some others. We're working on traceability. Again, I know some were worried about regulatory and about demands from that, but I'll be honest, who in every other product that we build in life, everybody is pretty traceable on that. I mean, I was talking to a friend that's at Mattel and how much they track and trace Barbie dolls. Again, you wouldn't think you do that, but how much information they have on track and trace. So you're talking about a basic throwaway, if you will, consumer product, and yet, a highly dynamic electrochemical, mechanical device of a battery. This information and this data to have traceability so that we actually know what we built, how we built it, where we built it, and to Chip's point, is it the right one that was built? We can also use that downline to satisfy those requirements to know in the field as we extend the life of these products through recycling, reuse, second life, and others. All of that data feeds in there. So, everybody's always been worried about like, oh my gosh, I don't know how we're going to be able to get to all this information and all this data. You're already producing it. It's already critical to your systems. It's going to help you with so many other things. We try to tell people that say, hey, this is going to be an onerous cost to add this in and it has no value. I would actually disagree with you. In fact, I would imminently disagree with you and tell you you're wrong, that you have a substantial opportunity to use it as a financial advantage and a product advantage. And in the end, you'll also be able to supply some of that track and trace information because it already exists. So that's my soapbox for the moment on how to extend that traceability all the way through the value chain.
All great points. All great points. So moving on to supply chains. So supply chains are also a major part of the scaling challenge, as we know. How do supply chain constraints impact a manufacturer's ability to scale production effectively and efficiently?
Gabe, you want to jump in on that one first, or I can?
You go ahead and segue in because you're kind of on a roll with supply chain. I'll let you.
I'm a recovering supply chain guy, by the way. I think recovering engineer, recovering executive, recovering electrician just depends on the day. Yeah, supply chain. I mean, obviously, we're finally at a stage where I would say supply chain is more robust than it has been. COVID didn't do anybody any favors, and actually, it exposed how fragile and small and fractured the supply chain already was. And I think for those of us who've been doing this a long time, when you look at the names of like, how many dry room suppliers, like people, say, hey, I need my dry room supplier list. And I'm like, yeah, it's like 3. And they're like, 3. I'm like, no, globally. I'm like, yeah, it's 3 that you can trust globally. And it's like, oh, coating equipment. How many there? You don't have 50 suppliers. This isn't, automotive supply list all over again, where you've got tier 1, 2, 3, and every list could have 50 names on it. You might have, 1 to 5 at maximum in some of these cases. Luckily, though, supply chain's gotten better. However, what I would say is some of our U.S. manufacturing that we were hoping for supply chain hasn't fully materialized. And so some of the supply chain concerns and considerations today, I'll just say predominantly, if you're going to be putting together a system, it's most likely for sure China is on your list. Secondly, Korea and Japan are going to be on your list. Taiwan has got some pockets of some capability now as well. And then you've got some pockets in Europe around kind of mixing some of your electrical equipment, some of your intermediary equipment, but, large scale full factory, some of the stuff we were hoping for has not materialized in all those countries where you can get a turnkey. Go into Asia and get that pretty much anywhere. You go to any other country or continent, you're going to get, pieces of the pie, but you can't buy the entire pie plus the ice cream on top. So that supply chain is a critical factor. Again, back to these automation and the systems and all this stuff. What it means is if you say, hey, I love me some German coder and some German mixer, and I want to use a US automation or a US assembler that's going to, supply sell equipment, say JR Automation and others. And then you're going to go get, some of your core equipment. You're going to get your dryer. You're going to get your formation and others from Asia. you're going to have to tie all that together. It's important, again, back to this backbone. So you got to be thinking about that in your supply chain at the beginning. How do they work with all those players, and can they implement those players together in a cohesive factory system? And I'll say there's a lot of folks that say they can do it. Go look at their factories and watch how fast they scale. If you want to see the best, portfolios, is go out and see somebody who's not bought a single system from one place or just cookie cuttered, or bought somebody's surplus system. That happens a lot. If you look at somebody who's bought a truly new system and they've done, I'll call it miscellaneous, or they've done, kind of picked from the menu, this backbone of automation and stuff is going to be absolutely critical to your supply chain not impacting you.
Yeah, Ben, you already said it. I mean, I'll say it again. Supply chain is just a major factor right now, especially with equipment lead times and material variability, right? So those directly impact, how quickly the manufacturers can ramp and how stable their processes are. As far as supply chain concerns go, we see customers that are trying to address this through, we say earlier engagement and more strategic planning. So we get, this is usually one of the first conversation topics that comes to mind with any new customer that we see, and it's right at the top of their list, right? It's very important. But some of the things that we see in that breakdown is there's also this strong push, right, towards, localization, which adds complexity, right? But it can be, an improvement, if you will, long-term for their stability. But with that, we've seen things, from localizing, right? There's, delayed ramp timelines, things that were 18 months to 24 are now upwards of 4 years. There's yield variability due to inconsistent materials. So kind of some of the, high level, call it strategic responses there are just, essentially closer supplier integration, right? We have to get better at that and closer with it. And then, digital tracking of the materials and the quality, which I think we all know that, right? It's just formalizing those systems and moving through that exercise. So, Chip, I guess, how do your customers tackle? I know you're deep in this and you see it, probably even far more than us. But how do your customers tackle supply chain constraints and scaling some of the battery module and pack assembly lines?
Well, for us, our customers are typically not process automation intensive like a cell manufacturer. So it's really more factory automation. It's more material handling. It's more precision assembly, things of that nature. So after the pandemic, we realized that we could not have the lead times that we had for certain key automation technologies, whether it was I/O blocks, PLCs, cameras, vision, robots, conveyance, dispense, fastening. No matter what technology you listed, that the lead times had just grown to enormous amounts. So put a lot of pressure on our supply chain team to build more strategic partnerships with those technologies. JR, as a system integrator, is primarily technology agnostic, although we have technology partners that we love to work with and that we build long-term relationships with, that we have access to a queue, an allocated inventory, which would allow us to shorten up lead time. So we bring that value to the customer, but the customer, what they can do is to, in the early design phase for the line, once we've got that, as I mentioned earlier, once we've got the layout understood, the process flow is clear, and the product design is maybe 90% there, then we will tend to get a long lead PO. Did I get some feedback there? Y'all hearing me okay?
You're coming in okay.
I am? Okay. So we'll get long lead POs and get those into the system. I mean, we know we've got to get that material on our floor. And then as the design matures, and then we know, okay, these are the physical attributes of this part and all of its associated components. Now we can kick off our end effectors, our end of arm tooling, all the touch tooling that interfaces with the material to bring it together in a precise way. Those tend to be shorter lead time technologies. We are also integrated with machine and fab technology, so we can do our own fixturing and tooling and things like that. So we can do those real quick. So we just tackle those long lead items from the beginning and have a strategy about that. And we try to get in front of that from a supply chain perspective internally, just to bring that value to the customer, saying we're aligned with these robot manufacturers on these robots, which are hard to get. we have good pricing, and we have good lead times. So it's really on us to bring value to the customer in terms of managing those technologies and allocating inventory for us.
Makes a lot of sense. A lot of sense. We talked about a lot of challenges today. So to navigate all of these challenges, manufacturers need a strong digital foundation. From everybody's perspective here, what kind of digital architecture is required to support scalable manufacturing operations? Gabe, you want to start there?
Oh, yeah, sure. The answer is in the question, right? Yeah, so to scale effectively, manufacturers need a strong digital foundation. But no, more seriously, right? So MES and SCADA systems play a key role in enabling that. So that includes, we'll start with the basics there. Things like consistent recipe control, full traceability, real-time visibility into what is happening on the line. But the real value is not just having those systems in place. It comes from how well they are integrated across the platform. So when I think of MES and SCADA and quality systems and equipment data, it's getting them connected properly. Manufacturers, need to be able to identify issues faster, respond with better context, and maintain more consistent execution across the lines, and even multiple facilities. So, and one of the common challenges we see is that quality is often isolated, or we call it islanded, right, within the four walls from the rest of manufacturing, which usually causes many issues that we won't dive into right away here. But process data may live in one system, quality data, in another, and engineering or maintenance information somewhere else entirely, and that makes it very difficult to connect cause and effect when something starts drifting or a defect appears downstream. So that's one of the big struggles we see now. So really, the outcomes we are looking for is, we want to be able to get faster troubleshooting, improved yield, and standardized operations at scale. And I think kind of, digging into these gaps and finding ways to connect them is what's going to get us there, right? Especially when we look in terms of quality. Root cause analysis and the speed to get there is just one of the major things we run into very often. Ben, do you want to add anything to that? I know you've seen a lot of things on the quality side.
Yeah, I think, again, your point, Gabe, about those digital systems, and what I'd probably note to everybody, again, hopefully this makes sense, is you got to define that digital backbone and that infrastructure and how you're going to deploy that. You should be starting at your early stage with prototypes. Like, that's the thing that people miss, is I think they having been, I'm going to name drop a few here, because hopefully these are familiar to some of the folks that are online. And by the way, this is no, plug for one or the other. It's just, as I look at, some of that legacy and ecosystem, when we were at, Battery Innovation Center, and had some great work there, but we would be, feeding that information over to start to, I'd say, build that recipe, that digital, not just the recipe for their technology, but their digital recipe. Folks are like, yeah, great, I'll go file it away, and then we'll worry about that when we get to scale. And it's like, but that's important to start to know and define and massage that at the very beginning. It becomes your framework or your fishbone. It defines your FMEA and your process FMEA as well at the very early stages. And so I've seen way too many times that we get done and then we go into a production factory or a pre-production where folks take, we see what they're doing and we're like, we covered all that. Like, we covered all that. What are you doing? And they're like, oh, you did? They're like, well, that was prototype. Like, how would that have applied? And it's like, because we were honing in, like, we were here, we honed to here, you should have started here, but you went back to this variable. That's definitely a big one. As you go outside a cell then and start to look at manufacturing at the broader scale, where I'm taking that and putting it, probably looking what Chip and the team are doing as well there. When you put those cells and put those in a module and pack, it's the same thing, by the way. In fact, that's another big gap that Gabe and I have seen extensively, is that cell understanding, that cell digital backbone and everything. It is critical to deploying into module, into elements and modules and into systems and battery packs that should go through to your CM and through to your automation. If you're using, JR for automation, or using Photon Energy for contract manufacturing, large scale, or you're doing your own manufacturing, you sure as heck got to feed that all the way through the system. So people like go put it in the freezer and forget about it. I'm sure everybody's done that. 9 months later, you're like, oh, that's where it is. It's in the freezer. You should have had that out on the counter using it all along the entire way. I think that's important about that digital infrastructure is you're growing it at the prototype. You must look at it all along the way, and then you've got to optimize on it in production.
Right. Kind of the last question here, guys, as we wrap up. And I'd ask you to look at this question through each of your individual lenses and how we look at this market. Can you share examples of challenges you've seen in real battery manufacturing projects, and what made the difference between a successful scale up and costly delays? Anybody
Do
like
you
to
want to
start?
kick this one off, or I can? I can
You,
certainly.
I've probably got way too many, and we'll be here too long. Gabe, you want to start, and I'll make sure I don't take too much time.
Yeah, maybe I'll
needs
just
to
keep
jump
it.
in
I'll
here
keep it
too.
short. I know we're
Yeah.
coming up on time, but yeah, one of the biggest challenges, right, is we see is underestimating integration complexity. We see this so many times, and delaying the digital system deployment. Those are the top two. If you have to put me on the spot and ask me right there, and we see them so often. So, when MES and SCADA are brought in too late, it limits their effectiveness and creates challenges during ramp. So I kind of like let's back up and say, well, okay, having said that, what does success look like? And for me, it's kind of that early alignment between automation and digital systems that has to be in place. Strong integration strategy from day one, and then a focus on process stability before scaling any type of volume. So scaling success is not about one system or technology. It's about orchestrating, the entire manufacturing ecosystem, if you will. So that's kind of the big takeaway there, I would say. Ben, I'll let you chime in there.
Oh, I'm gonna drill into one point you just said, Gabe, is strong system before you scale. If I could be vulgar for a minute, holy shit. The biggest problem in a lot of the United States and other countries is we're trying to play catch up to China. And so it's like scale and worry about the problems later. By the way, in a lot of other industries, data centers, they can get away with this today, right now, hyperscalers and others. You can get away with playing that hockey stick. You are going to be another failed battery company on the chopping block being sold for pennies on the dollar, everything that you've worked on, if you scale without your system understanding and your system deployment first. Seen it way too many times. I could run through the list of names. It's names that everybody knows and sees, and you read about another, the unfortunate demise of another battery company. I can tell you, easily, I won't say 9 times out of 10, sometimes it's just absolutely, bad leaders who run it into the ground. If we take them out, the other 8 out of 10 times are because they actually don't know. They know their science system they need to deploy, but no one's thought about the factory system and the production system. And I think that's an important aspect. And I'm going to leave on this point with Gabe to hammer on is I think that's one of the things we actually have to relearn here in the United States. When I started in manufacturing, in the 90s, we knew how to put in systems. We knew how to make those the backbone. By the way, we didn't have some of the amazing tools that we have nowadays. We had just pure grit and hard work and people, even when I started 30 years ago at this. But with all those systems and tools in place, we don't use them the way we used to. We just buy CapEx, deploy it, and then we iterate to get to our scale. That's the wrong way to do it. Every battery company, or again, not every, large portions, large swaths of battery companies over the last 20 years and even the last 5 to 8 years have failed miserably because of not understanding the system that they need to deploy and the science behind that as much as they understood the science of the actual electrochemistry.
That was There she is.
All right, we're going to go ahead and open it up to questions from the audience now. We have one so far, but if you have anything that you've been thinking about throughout this discussion, feel free to drop those in the questions tab and we'll answer those now. So to kick it off, we have, given all the headlines about the EV market struggling in America, is the industry actually in trouble or is something else going on?
That's a fun one there. Then I can jump in, or do you want to start?
I'm gonna
I
let you
have.
go. I'm gonna let you
All
go
right.
again. So I don't just,
All
sometimes
right.
they say don't let your mouth overrun your other things. So I'm gonna let you talk first. So I slow myself down.
Right. So I'll throw my opinions out there. I'd say, the market hasn't died, right? I think that's kind of some of the doom and gloom we see, but it has pulled back, but there's, some positives there. I mean, gas prices are certainly reigniting some consumer interest. I mean, we've seen that even in the first quarter of just how EVs are doing and some rising points there. But for me, I think the stability that it may be bringing could be a healthy signal. So, we talked about, disciplined execution versus capacity, right? And, prior, 2-3 years plus, right? It was, everybody was going gangbusters for capacity, which, frankly, for me was terrifying. And I think this more stabilized, disciplined approach is somewhat refreshing. So I'm very happy to see that, if you will. And I think, the future is really going to hinge on the fundamentals and not just the policy, right? So, who can make affordable products, have, very, be intelligent about how they price things and how they differentiate, and how they set themselves apart with how they approach, what they're doing, whether it be ramp or producing, a specific product that ties into the industry. So, I mean, having said that, the macro headwinds are real, right? There's tariffs and inflation and the economy. It's not just EVs, right? All car purchases are kind of suppressed right now. But having said that, I still think it looks positive, and we're just kind of in that downturn, which we've seen. I know all of us here, I think, several times before. So I think we're going to come out of it.
Yeah, in our business, we've got we work with the automotive OEMs, so the folks that are building cars, and there's been a clear a pause and a pivot from full-on EV to a 2-year delay in cycle plans to a pivot to a more balanced portfolio, more nuanced, more thoughtful. You can look, there are certain Japanese OEMs that have had a more holistic approach to, I should have these technologies for these markets. So instead of throwing the baby out with the bathwater, the OEMs that threw the baby out with the bathwater are in the midst of massive write-offs and having to redeploy these huge investments that they've made to capture some type of growth. And a lot of them are pivoting towards energy storage to support the hyperscaling of the data centers. So we see that as a 2-year window, really, and that the automotive OEMs, having made a nice course correction in their product portfolio, and then the battery technology catching up to give us now lower range anxiety, higher quality. We're going to see the automotive XEV, so plug-in hybrid, full-on electric, ICE, diesel, you name it, is going to be nicely balanced with good demand in a couple of years. I honestly believe it. So I think 2028, 29, 30, we're going to see it pick back up, and then we'll see some nice growth in the industry, I think.
Just to kind of layer on top, and Chip, some great points in there, and Gabe as well. My take on it, probably a little Mark Twain, Samuel Clemens. The story of the death of the battery industry is an exaggeration. It's not dead. The industry still grows across the board. This year alone, we'll move from 7.5 devices to 10 devices that are battery powered on or around you every single day. So you can't tell me it's dead if we're scaling, nearly another 40-50% of battery products. The automotive market is fickle. chasing mandates has been a problem for the automotive industry for a long time. Frankly, as a battery guy and long-standing, everybody knows I'm a big battery guy. I've put, now about 1.25 million miles on electric vehicles, personally driven, flown, floated. I mean, whether it goes on water or goes on ground, I'm a big EV believer. However, the mandates and the way we went about it, without going too political, absolutely the wrong way. I'm actually glad that we did the reset we did, and got a chance to get back to reality, because we skipped over diversity in our supply chain. And if I get into a diversity discussion, is we need a diversity in the reason electrification should have come along and will come along and will still stand strong is because of it's a tool in the toolbox. It's not a replacement tool for everything else. Batteries are not a replacement for everything else. They're a tool in the toolbox. They're an innovation. They're an enabler. They're a capability. And so I'm actually glad that we're seeing that. Now it disappoints me that, so much of the automotive industry had to pivot so hard or pivoted the way they did versus taking some logical steps like we've done in other industries. Again, whole reason to unpack there, from geopolitics to mandates to stuff that I completely, went against, voted against, screamed against in my own industry, was an outcast in some ways, because I'm not a believer in full electrification. I believe it's wrong. I think we need appropriate amount of electrification, and I believe batteries will play a critical role in hybrids, in full electric, and also in everything else that's around us, along with a lot of other products. So that's my battery soapbox for a minute. So I'm actually glad we're back to what I've always told people. When I started in the 90s with this, looking with the Impact program, which became the EV1, which was a lead acid battery pack, and then we moved to nickel metal hydrides and did the Toyota Prius, did the Allison hybrid, and we got into long-standing and still deployed nickel metal hydride today, pretty much going away because of lithium ion. And now the continued trend of lithium ion. If you actually look at all the outliers that everybody's tried to put on this damn battery curve, and also on the scaling that everybody's going to go from, it sort of looks like, science companies today is, hey, I've produced, 1,000 cells, I'm going to produce 1 million, in 6 months. Ignore the science, ignore the backbone, ignore the data, ignore the automation. I just put brute force at it and I'll hit the hockey stick. It hasn't worked. And so I think we're good. We're on a logical trend line up. And to the topic of this return on investment for this discussion and for the group, is our return on investment is to stay on that steady course. There is more, there will be more, there is more growth of electrification. There is more need for batteries. There are emerging areas where we can diversify how we use batteries. Chip, you put in, data centers and energy storage. We're finally seeing the importance of those come about as well. So if anything, for me, for everybody on this call that's listening in, is stay the course on scaling, but make sure you got the systems and the backbone in place, and then it's intentionally selected.
All right, thank you guys for that. Another question here regarding SCADA and MES systems. What are some of the KPIs for batteries, specifically relative to other devices that have a subset of mechanical, electrical, chemical, and thermal components?
I have to have you. I lost you on the first part of that question.
I'll read it again, and then I can also send it to you, Gabe. Regarding SCADA and MES systems, what are some of the KPIs for batteries, specifically relative to other devices that have a subset of mechanical, electrical, chemical, and thermal components?
So KPIs for batteries. I may have you send that one to me so I can read it to you, because I still lost you on part of the end.
I think there may be the question again. Hopefully we get this one right. If not, apologize. With those key performance indicators, I think because of the end of that question, it was as we look at those SCADA and MES for batteries, how does that deploy? How do those impact downline? Is that correct, Ellie? As we kind of read, it's not at the battery stage. It's at, as those go into systems or deployment. Is that? Again, it's a good. I think it's a good question, but it's long. Okay, maybe I'll jump, Gabe, and you can try. But I mean, obviously, all the basics of all the data sheet, information that comes out of your SCADA and MES, all the stuff we're tracking for capacity, for, impedance, for yield data, for variance that's in those, starts to play. It very much plays downline because as I get into these very large scale systems, one of the worst thing I can do is have an infant failure that comes because of a cell that's outside of tolerance or outside of parameter, or is my Herbie, if people are familiar with that from the goal, if it becomes my Herbie, I have that information upstream and I should be tracking that. My system should be deploying that. It also plays into life cycle as well. Being able to look at impedance, look at original capacity versus my current state of health capacity, to look at my temperature ranges and stuff across those, and what would have been my curves and my process indicators that I use to kind of birth that product are really important in the field to be able to do a health check to say, am I good? Am I aged out? Am I ready to do something else, or am I ready to to be recycled and be put back into a new battery with a new set of KPI defined? Again, I hope we answered that. That's a start of the right answer to the question that was asked. But Gabe, I don't know you or Chip's comments as well.
Yeah, I'm trying to think of how to dive into this. So, there's even, a platform, Mesa puts out, kind of what these, call it the top, ish KPIs for us. So we look at, we look at manufacturing in this case specifically, we're looking at things like OEE, throughput, cycle times, capacity utilization, first pass yield. So I'm trying to just figure out the root of the question here. But as we dive into other systems, right, Ben mentioned, you mentioned some of these, like, if we look at formation specifically, right? So we're looking at things like our thermal set, our capacity, like in amp hours, our DCIR, so the internal impedance of the cells that are getting measured, self-discharge during some of those heat soaks. So yeah, without, just listing KPIs, which maybe that is what the root of the question is, which I'm more than happy to get into a discussion, or actually have entire spreadsheets dedicated to certain breakdowns of processes and pieces of equipment on what KPIs align there for things like cell manufacturing, right? So I'm hoping, I know that's probably a poor answer, but I'm just trying to frame and try to get the correct answer that's at a high level for you.
Yeah, that's great. And we can always follow up with that question too, if there's any other additional context we want to add there. But we are at time now. So thank you to our panelists, and thank you to everyone who joined today. Really appreciate you all taking the time to come learn about this with us. If you do want to get in contact with any of our panelists, if you have any additional questions or just want some advice on how best to handle your strategy, please feel free to reach out. You can reach out to me directly at ellie.allenbathe@flexware.com, or you can reply to that email I'll be sending you with the recording link, and I'll make sure you get hooked up with the right person. But again, thank you for joining us today, and I hope you have a great rest of your day.